Okay, so I've asked that you have your formula sheet out, so the one that we used for your test, you should have that out because we're going to be using it. Now on EQAO, you will get a brand new one, so nothing will be highlighted. So you have to remember what was highlighted. Does everyone have their formula sheet out? Okay, we're going to do the first review question. It says here, perimeter of composite figures. Yes? Okay, I'm going to get you to share with your brother. Then okay? If the person beside you does not have it, I'm going to ask that you share. Okay? And then I can look at getting you some more copies. So it says here, important things to remember. When you are calculating the perimeter is talking about the distance around a shape, and you must determine all unknown side lengths. Okay, that's your first step. Second step, you add all the sides together. They must be on the outside, so we don't include sides on the inside. And to remember your units. And your units are meters, centimeters, millimeters. It's the same unit. So perimeter is the outside of a shape. It's talking about the border. And again, in EQAO, it won't say find the perimeter of this composite figure. It will say something like, how much fencing will you need? Fencing's talking about the outside of a shape. So here, I'm finding the perimeter of this. So I'm going to highlight the outsides. And the first step here, it says determine all unknown side lengths. Well, let's start here. I know from here to here is 40 centimeters. Do I know this side length here? Jonathan? What is it? What is it? Okay, and how do I know that this is 40? Yeah, I have a tick here and I have a tick here that each tells me that those side lengths are 40 centimeters. Now, do I know this side length here, from here to here? Do I know that side length? Andrew, do I know it? No. It's a semicircle, right? I don't know it. So I have to determine what this is. And if you remember, the only shape I need to use a formula for is a circle. So, Ben, what formula am I going to use to help me determine this side length? Good. And why did you choose that one, C equals pi d? Okay, good. But why else did you use? We have two formulas that you can use there. C equals pi d or C equals 2 pi r. Why did you choose pi d? Jonathan, can you all vote? Why would he choose pi d? Why does that one? I'm given the diameter here of 34 centimeters, so I use that. So, Tristan, what will I write on my next line here? C equals what? Tristan, what do I write next? 3.14? Yes. Okay. Noriel, what do I get here when I do this? What would I write down on my next line, Noriel? Okay, is that the answer that I'm going to use there, Bailey? No. There's something that happens here that I have to be careful of. What is it? Tristan? Well, good. I divide it by 2 because it is a semicircle. Okay, so what do I get for that? Nick? Good. So I now know that that side length here is 53.33 38 centimeters. Now, Lucas, when I want to calculate the perimeter of this, what do I have to do? Good, I add up all the sides. So I'm going to write here P to show that I'm calculating the perimeter. And then what will I write in here, Lucas? What will I add together? Good, and why don't I add 34 in there? Because it's not on the outside, that's on the inside. So what do I get for a perimeter here, Jonathan? And why will you lose half a mark there? Why will you lose half a mark? Yes, so centimeters. Okay, does anyone have any questions about that? That's a perimeter of a composite figure. If you don't have a calculator, can you please come and get one? Okay. Next, we're going to do area of composite figures. Now this one looks familiar because I did ask this on a test, so we're going to review it. It says important things to remember. Determine the simple shapes. Simple shapes are the shapes that are on the front of your formula sheet. Rectangles, triangles, trapezoids, parallelograms, circles. You're going to find those. Then you calculate the area of each simple shape. Then you will either add or subtract the areas together. Remember, you subtract if the shapes are on top. You will add if the shapes are beside each other, okay? Don't forget that the units are squared. So I have all these helpful tips that will help you. Now, Andrew, what are my simple shapes here in this picture? It says Jackson is buying paint for his wall. First of all, you're painting. So if you are painting, you know that you're not going to be painting this. You're not painting just that. You're not painting the border. You will be painting this wall. Because I colored that in, that means I'm calculating the area. So I need to find my simple shapes. Andrew, tell me one simple shape here. Okay, so I'm going to write here, rectangle. What's my second simple shape? Good. So I've identified my simple shapes. Ben, what am I going to write down for my rectangle? I want to write down a formula. What formula will I use for that? Good. A equals L times W. Now, Jonathan, what will I plug into that formula? Good. And Tristan, what do I get when I do 12 times 2.5? Meters squared. Okay, good. Noriel, for my triangle, what's the first thing I'm going to write down here? Excellent. A equals base times height divided by 2. Now, Bailey, what am I going to plug into this? You do. How do I find this height? The height of this triangle, so Bailey noticed something very, very important here. Here's my triangle. And she noticed I don't have a height. Bailey, how would I go about finding that height? So the height just goes from this point to this point. How do I find that? Not divided by 2. That's not half. It may look half, but I like that we're going to take this 7.5. What do I do to that 7.5? Lucas? And where'd you get 2.5 from? Yeah, from here to here is 2.5. So from here to here is 2.5. So I just want to remove this length here to get the height. So I'm left with the height is actually equal to 5 meters. So Nick, what will I plug into that formula now that we figured out what my height is? Good. And what will I write next, Lucas? Good. So it was 60 over 2. A equals 30 meters squared. Now I'm not done here. I have to find the total area. So, Andrew, what am I going to do here to find the total area? Good. Why do I add them? Yeah, they're both part of it. These shapes are beside each other, not on top. So I write the totals 30 plus 30, which gives me 60 meters squared. Anyone have any questions with that? That's area and perimeter of composite figures that we've just went over. Okay, volume. Remember, volume is talking about a 3D shape. And if you have 3D shapes, you should be looking at formulas that have 3D figures. Okay? You want to write out the formula. Remember that pi is equal to 3.14. Remember to put brackets around what you substitute in the equation. And then your units for volume are cubed. So I have here, it says a gift shop sells water-filled spherical globes that sit on a base. Determine how much water the globe holds that has a radius of 6 centimeters. So the first thing I need to do is figure out a formula. Ben, what formula will I use for this? Good. And it's important to remember that that is a cubed, not a squared. So now I need to substitute this information in. So Jonathan, what will I write on my next line? That's it? Yeah, don't forget the divided by 3. Now when you're doing this, I want everyone to type into their calculator the top line. Type in that top line. So what do you need to do, Jonathan? This is EQAO. What would you have to do? You would need to make sure that you have one of my calculators. Okay, what do we get for that? Tristan? So again, what? No. So what do you need to get? Get a calculator. Noriel, what did you get, sweetie? No. Okay, if you're not going to get this answer, I need you to ask me for help so that you know what to do. Bailey, what did you get? Good, and that's still divided by 3. How many of you got that answer? How many of you did not get it? Okay, so what you have to do, you do 3.14. Oh, sorry, 4 times 3.14 times 6. And then this is your exponent button. So you go x, y, and then it's to the power 3. So you go 3 equals. Okay? Okay, so we would go 4 times 3.14 times 6. And then your x, y button, that's like your exponent for something bigger than 2. You hit this, x, y, and then we say to the exponent 3 equals. Okay? You got it? All right. Okay. Now I still need the final answer, which is what? Lucas? Or somebody? Who has the final answer here? Bailey? Pardon? 904.32 centimeters cubed. Okay, any questions with that? All right. Now we're going here, Pythagorean theorem. If I had to make well, I don't even know. I know you have a similar question like this inside your books that are due on Friday. So Pythagorean theorem, it says, important things to remember. The hypotenuse is the c side. It is across from the right angle. So I have c squared equals a squared plus b squared. That's our formula. That is a formula you will have to remember. That is not given to you on your formula sheet. So you need to make sure that you remember that. Okay, the opposite of squaring is the square root. It says here, determine the volume for the following shape. Okay, Andrew, what is the formula that I will use for the volume of that shape? That's the formula for volume of that shape? What's the formula for the volume of that shape? Okay, so Ben, do I know what my radius is here? What is it? Good. How'd you get that it was 6? Good. So I know my radius equals 12 divided by 2, which gives me 6. Ben, do I know my height? No. You're right. What information am I given here? Does anyone remember what that word is called? This 10 is not the height of the cone. What is it called, Andrew? The slant height. This is the height. The height goes straight up and down. See how this one's on a bit of a slant? This is the slant height. So I can't plug that 10 in. If I plug the 10 in, I get the wrong answer. So if you're given the slant height and ask for the actual height, you have to use Pythagorean theorem. So we're going to draw this triangle here, right here. So Jonathan, what number goes on this side on the bottom right there? What number? Good. And again, I know that the distance from here to here is 12. From here to here is 6. Okay? What would I put here on this side? 10? How about here? Yeah, for height. Good. So I've just labeled my triangle. I want to find the height. I was given the slant height. I was given this. Now I need to determine, what is my C side here, Tristan? Yeah, so C is my hypotenuse, so I draw my arrow across, so this is my C side. It doesn't matter what I call A or B. So now I'm going to plug it into my formula. My formula here is C squared equals A squared plus B squared. Noriel, what will I plug into this equation? Excellent. And Billy, what would I write on my next line? I got to simplify that. So do this math, 10 squared. Good. Equals h squared, can't do anything, plus 6 squared. Good. Okay, Nick, what would I do next? I need to figure out this height. So what do I got to do? H is on this side, so I want to get h by itself. So what would I write? Excellent. Lucas, what would I get when I do that? Good. And Andrew, am I done here? Is my height 64? No, what do I have to do? Very good. And what do I get when I take the square root of 64? Very good. So now I know what my height is. I had to do all that work just to find the volume. So Ben, to answer the question here, what would I plug into my formula now? Volume equals what? Times 6 times 8. Good. Excellent. And Jonathan, what would I get on the top when I plug that in? Pardon? Good. 904.32. I want everyone to type that into their calculators and tell me if you get that. 904.32. How many of you were able to get that exact answer? Good. Okay. I still need to do what to this, Jonathan? By, oh, it is 3. I don't know why I wrote a 2 there. You're correct. 3. So I get the volumes equal to what, Tristan? What? Very good. Okay, so that was 2 weeks of measurement crushed into 20 minutes of review. So what you're going to be doing next is a booklet, a little worksheet. So this is what we're going to be doing.